Well, hello there. Welcome to another day of stoichiometry with Mr. Arnold. Hey, let's get right down to it. What we got going here today is what we call the limiting reactant. And what's the limiting reactant? It is the reactant that limits the reaction. What? Well, if you have an ingredient that runs out, say you're making peanut butter sandwiches, right? If you run out of bread, you cannot make any more peanut butter sandwiches, even if you have all the peanut butter in the world. The bread limits the amount of sandwiches. Well, the same thing's true for chemistry here. We're going to limit the amount that can be made because we're going to run out of one of the ingredients. And the ingredients are the reactants. So we're going to get started here in a second. Let's get me in a position where I'm not in the way. How's that look? Okay. Oxyacetylene torches. That's the torches that we use to like a blowtorch type thing. Right? They use them for welding and stuff too. Are used for welding. They reach temperatures near 2,000 degrees Celsius. That's pretty darn hot. These temperatures are due to the combustion of acetylene gas, which is C2H2, and then it reacts with oxygen. That's a combustion reaction, right? All right. So here we have the balanced equation. We have the acetylene, that's the C2H2 plus oxygen, forms carbon dioxide and water. All right. So that's the setup. Let's see what we have. Starting with 125 grams of both. Okay, here's the difference in this type of problem. We have two givens, right? Just as I said earlier, you can only have one given per table, right? So since we have two givens, we need to have two tables. All right, and it says what amount of water is formed. All right, let me set up my equation. Right? Remember, I like to write my givens right on the balanced equation. So it says we have 125 grams of the acetylene. It also says we have 125 grams of the oxygen. All right? And what we're trying to find in both cases, you know what I'm going to do? I'm going to put one in green and one in red. Right? They're separate. They're going to react together, and we're going to find out how much water we can make, okay? So how much water we can make. So we're going to put a question mark, and we're finding grams. And again, it's water, and so we'll put a question mark in grams. I mean, it's both the same. You wouldn't have to write that once. It wouldn't matter, right? Okay. So we have grams, and we're trying to find grams. So the maps in both cases are going to be grams to moles to moles to grams. That's our pattern, right? We have to follow that pattern. All right, let's start off with the acetylene. All right, so I'm going to take 125 grams of acetylene, that's given. I'm going to put that in my first section of the table. 125 grams of C2H2. Okay, now I'm going to go ahead and put my unknown in right now, right? I'm going to go try to find what I'm going to find. And here's a little trick to help you keep everything straight. We're just going to go to the back side and put grams of H2O. That's what we're trying to find. Right? So now we have both sides of our factor label table. Let's work in, right? We have the grams, we have the grams, we have the grams. Let's find the moles. All right? And so I'm just working through my table here, and I'm doing my givens in red. So moles of given would be my next column, would be C2H2. Remember, you only allowed two things, the given and the unknown. And then the purple will be moles of H2O. All right, little bit variation on my purples. Sorry about that. Okay, now we're to this point. Now we can do our crossing out, right? So I'm going to try to color code this as best I can. We have to cross out grams of C2H2, cross out moles of C2H2. Okay, did that make sense? If you're not sure what that means, well, here we go. And now we'll do our water. Moles of H2O. All right, so now I have all my labels in the right spots. Now I just have to have the right numbers. If I have grams over moles or moles over grams, the moles will be 1. And the grams is the mass from the weights from the periodic table. So if we slide down here real quick, we can see that we have carbon right there, and carbon's 12. So we have 2 carbons, that's 24, and 2 hydrogens, which is 2. So that's going to be 26. Oops, come here. Do I have room over here? No, I do not. So this is 26 grams. Okay, I'm going to go do the grams for the water, right? And we know water's mass, right? It's 2 plus 16. So that's going to be 18 grams. And I'm trying to color code, so give me a second. 18 grams. Okay. If you have grams over moles or moles over grams, the moles is always 1. Let's put a 1 there. All right, now we're ready for the mole ratio. Okay, now a few people in your papers, you've been messing up on this mole ratio. It's super easy. It's the only new thing we have this chapter, really. It's super easy to do. All we have to do is look at the balanced equation. So let's do moles of water first. So when we go to water, oops, there it is, right? That big 2 in front of there, that is what we're talking about. That's the number of moles of water in this equation. So we put that 2 right here. Acetylene, the C2H2, it's right here. And look, it's also a 2, right? Now we could reduce that if we wanted to, but you know what? I already wrote that 2 down for the water, and I don't care if I have to punch that in the calculator. It's not going to hurt my feelings at all. Right? So right here, we're moles of acetylene. We're going to put a 2 there also. And then that part of the problem is done. All right, now, you can, if you feel you want to, you can punch that in right now. Or you can wait and do them afterwards. I like to do mine as I have it set up, so I'm just going to punch it right in the calculator. Now, some people, when punching this into your calculator, have been screwing this up too. When you put this in the calculator, if it's on the top, you're going to multiply in front of it. If it's on the bottom, you're going to divide. So I start by putting in my given, 125. All right, that's set. Since 26 is on the bottom, I put divide by 26. Since I have 2 on the top, I put times 2. I have 2 on the bottom, I put divide by 2. I have 18 on top, I put times 18. I have a 1 on the bottom, and I'm not going to put that in the calculator, okay? And then I push old enter and see what happens. And I got 86.5. Let's write that down. Don't circle it or anything yet. We're not done with it. And that would be grams of H2O. Okay, we are not done with this problem. Let me see if it shows up here. There it is. Okay. Now, we have this whole other section. And again, remember, whoa, I'm just barely peeking. Hey. Okay, so we have this whole other section here, and I'll just start myself over here, okay? And then I'll move halfway through. So we have the same given, but this time it's 125 grams of oxygen, and we're going to change that again and solve for water. Now, the reason I'm solving both for water is because the problem asks how much water. And I'm also using it for comparison. So this is like a shortcut. Believe it or not, this is the shortest way to do this problem. You could do it in 3 steps, or you could do it in 2 steps. And I'm doing it in 2 steps. All right, so let's start this out here. So we have 125 grams of O2. We're trying to find H2O. Again, I'm filling in the outsides first, right? So I'm filling in my outside spaces here. Well, I'll just go right there. So I'm filling in the outsides, and I'm going to work my way in. So it's going to be grams of O2, moles of O2. Okay. Grams of H2O, moles of H2O. All right, did you see how I did that? And look at our pattern. Grams of given, moles of unknown, grams of unknown. All right, we're ready to do the numbers. We're ready to do our crossing out. So we have grams of O2 here, moles of O2 here, moles of H2O down here. Do you notice what I did there? I just cross, 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 cross. Okay, now we're ready to make these equivalent. For grams over moles, moles over grams, the moles is 1. The moles is 1. The grams comes from the mass in the periodic table. This is oxygen, O2. I hope you know this one already. There we go. O2, 16, right? 16 times 2, so 32. And I bet half of you knew that already, if not more than half. And then we're going to go do our water next. And look, it's already here. 18 grams, 1 mole. Okay, mole ratio time. All right, and I have to move this down just a little bit, and I need to have my pointing picture. There we are. Get this over here so you can see me. There we are. Okay, again, this is where people have been messing up. So we had moles of H2O over moles of oxygen. So we have those two things right there. They're both moles. That's called the mole ratio, right? Moles over moles is making a ratio. So we have to go back and look at our balanced equation and find out what that mole ratio is. Now, we go up, we can do the first one. This is the water, right? It's just the big number in front, so that's 2 H2Os. And then we look for oxygen. I look right above here, and look, 5. So there's 5 O2s for every 2 H2Os forms. So 5 moles of oxygen would make 2 moles of water. That's what that means. And we call that the mole ratio. So I have that all set up now, and now I'm going to punch this into the calculator the same way I did before. It doesn't show up very well when I do this, so I can't really show you a picture. You know what I could do? No, I won't do it. All right. So we have 125. I was going to put the calculator on the iPad, but then you wouldn't be able to see the problem. So we have 125 divided by 32 times 2 divided by 5 times 18. Right? I know it's backwards, but you can see I put divide. I didn't use any parentheses. And that's 28.1. All right. Most important part of the whole entire problem is right now. So do not look away. This is huge, okay? So what we're going to do is we're going to look at those two numbers, right? Those are the amounts of water that can form. The top one was from the acetylene. The acetylene can form 86.5 grams of water. That's a lot. The oxygen can only form 28.1 grams of water, right? So what that means is that the oxygen ran out before we could use all the acetylene. Let me say that one more time. Since it made a smaller amount of water, that ingredient ran out first. The leftover acetylene can't react without oxygen, right? So it would never make this amount. That amount can't be made with that amount of oxygen. So the number that is correct, the amount of water that can be made, is the smaller number because the other ingredient has run out. I should say, because their ingredient has run out. I said that kind of backwards that time. So, because the ingredient has run out. So let's look at this problem again. Okay, I'm going to put myself right in the middle because that doesn't really matter. We don't have to see the numbers, right? So, here's the ingredients, right? They reacted together. The oxygens ran out, right? The oxygens ran out. Extra acetylene. Oxygen ran out. The amount that was made had to be the smaller number. We just said that. Okay, let's give these names. These are the reactants, right? They're right up there. They're reactants because they're on the left side of that arrow, right? So one of the reactants limited the reaction. It stopped it. That is called the limiting reactant. So we're going to call oxygen all right. The limiting reactant is O2. It ran out first. The one that is left over, the one that is in excess, the one that has extra, excess means extra, is acetylene. All right, one more overview. 2 givens, 2 tables. Smallest answer is the correct answer. The reactant that makes the smallest answer is the limiting reactant. The reactant that made the other number, the bigger number, the one that didn't truly form, is the excess. That meant those ingredients are left over. They're not used up. They're still in the container, right? They're not gone. They're still there. They're still acetylene. It's not changed. It's the excess. There's extra of that reactant. And that's all I got to say about that. All right? So these are limiting reactant equations. If you follow my pattern, and the ones that I'm doing are specifically asking for one product. I'm going to keep it simple. Asking for one product. We solve for that one product, pick the smaller answer. The one that made the smaller answer limiting. The one that made the bigger answer is the excess reactant. All right? And you know what? This paper only has, I think it has 6 problems on it, minus the one I just did. But this is going to be the homework for both today, or not today. Yes, today. It's for me, it's the day before. It's still Wednesday here. Where you're at, it's Thursday. But so these are for both Thursday and Friday, and this will be the homework. If you want to do it all at one time, that's fine. All the problems will solve in a very similar way to this. So that's it for until after break. So everybody have a Merry Christmas. Hopefully you catch up on these things. If you're missing homework, get that turned in, all right? Turn in as much as you can, and hopefully we can get everybody passing that, and hopefully we can get everything right. If you do something and I mark it wrong, and I'm circling, I'm marking, I'm grading every single thing on those papers. If I mark it wrong, I'm going to circle it or whatever I have. Maybe I'll write an explanation of why I circled it. Maybe I won't. Depends on the situation. But you can resubmit those. Fix them, resubmit them, and you'll get your points back. All right, so watch your grade that way. You know, there's no reason we can't get everybody get 100% on all these homeworks, and then we get into the test. It's going to help because you fixed everything that was wrong. It's going to help you do better. You're going to understand what you did wrong and fix it. And plus, it's a little buffer, right? A buffer for your scores when you get the test. There are so many things, so many steps in these problems. It's easy to make one little teeny mistake somewhere and have like a ripple effect. Okay, so just be careful. If you understand the concept, you're going to do fine. If you don't understand what we're doing at some point, it's going to come back and get you. So you have to make sure you understand why we're doing it and what we're doing. All right. That's enough of the lecture. So, hey, again, have a happy holidays. And it's snowing right now, and maybe you'll have a white Christmas. It's going to be a week from now, so who knows. And enjoy your break after you do this paper. Attendance tomorrow will be for the second part of this paper. So the first 3 for today's attendance, second 3 for tomorrow's attendance. Cool? All right.